Hey, it's Workbench Quagmire, back with our free code camp Python certification in 100-ish days. We are on day 81. Yes, day 81 of our free code camp Python certification. So today we have this implement the Tower of Hanoi Algorithm problem. I'll just go ahead and let me make this small. So implement Tower Hanoi Algorithm. In this lab, you'll solve a mathematical puzzle known as the Tower of Hanoi. The puzzle consists of 3 rods and a number of disks of different diameters. So here's the visualization of that. The puzzle starts with the disks piled up on the first rod in decreasing size, with the smallest disk on top of the largest disk at the bottom. The goal of the Tower Hanoi puzzle is moving all the disks to the last rod. To do that, you must follow 3 simple rules. You can move only topmost disks, you can move only one disk at a time, and you cannot place larger disks on top of smaller ones. To fulfill the user stories below, your objective is to fulfill the user stories below and get all the tests to pass to complete the lab. User stories basically are the rules. You should have a function named Hanoi solver. It takes an integer representing the total number of disks. Hanoi solver should solve the puzzle following the rule of 2 to the n minus 1 moves, where n is the total number of disks. And the Hanoi solver function should return a string with all the moves taken to solve the puzzle, including starting arrangement. With each move on a new line, rods should be represented as lists of integers. The smallest disk is represented by the number 1, and each rod separated by a space. For example, Hanoi solver 3 would return the following. So basically our starting state, and then if you thought this moved, thought we had an animated GIF here, but maybe we don't. Maybe we did before we solved it. Basically everything's there. You move the topmost disk to the target rod, which would be this one over here. Then you move the secondmost disk to the auxiliary rod. Then you move your smallest disk to the auxiliary rod. So you have a stack of 2 with the smallest and the medium. You move 3 to the target rod. Then you have to move 1 to the starting rod, 2 to the target rod, and then 1 to the target rod. So that's the solution there. You can actually see it on the screen over here. So that's what I tested for. And so your tests are, you have a function. You can pass the first 3 tests just by creating a function, basically. And returning an empty string. So then you have to basically create the algorithm to solve the remaining of these. And that's it. So I had to do some Googling about it because I didn't know how to do this. But basically the very top here is pretty simple. We need to create our rods, our initial stack. So the way we do that is we have the 2 empty rods down here in a list. And then we create a list, this range of, in this case, it would be range 3. We have a start and an interval. So we end up creating our initial state using, it's a list. And when we record this, we get this first line here. This is our initial state. So we create 3 functions in here. We need to record the state every time we make a move. Here you can see we record the initial state, and then we need to have a function to move a disk. So we need to have a from and to rod, and then that's just going to take the topmost disk off. So the disk is going to get popped from the from rod and appended to the to rod, and then we use our record state to record that change. So first one over here, we have 3, 2, 1. Our first move is to move the 1 to the third rod, and we record the state. Then we have our Hanoi function, which is the number of disks, the source rod, the target rod, and what the auxiliary rod is. And you see when we call it down here recursively, we define, n is the number of disks This is a 3 in this case. Our starting rod's 0, our target rod's 2, and our auxiliary rod's 1. So when it runs this function, we have to have a base case because it's recursive. So there's our base case. If we don't have any disks left, then we just return the function. And then we have 3 steps here, which is we run this, which will unstack our smaller disks because it's k-1. We move our largest disk from our source to our target, and then we restack our smaller disks. And so you can see here we got source. This is our target. In this case, it's our auxiliary. We're going to stack all these from the source to the auxiliary, and our auxiliary in this case becomes our target because there's nothing there yet. Then we move our disk from source to target. So this is our third one. This is basically what you're seeing on this between these 2 steps here. And then we restack everything onto the target rod. So we do that by calling this recursively, and then we return our list as actual strings that are joined by new lines, as it says in there. So, and there's just that's in there for the test. So you're going to have to go out there and probably, like me, I had to go Google about it and figure out. I could see it, right? I could see it. I could play this game all day long, you know, by hand, but writing code and figuring out the recursive part of it and this whole source to aux, target, aux to target source thing. I had no idea how to do that, so I had to go look it up. But that's the implement the Tower of Hanoi algorithm. And thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.